11.2a homework, simplify by multiplying. So 2 times 8y, 2 times 8 is 16, so you end up with 16y. Find all square roots of 25. A square root basically is asking this question: what multiplied by what is equal to 25? Or to put it another way, what squared is equal to 25? And the answer to that is, well, 5 times 5 is equal to 25, or 5 squared is equal to 25. So the answer to this must be 5. Now, that might seem like a good answer, but there's a little bit more to it because it says all square roots. The thing is, a negative 5 squared is also 25. So negative 5 times negative 5 is 25, just like 5 times 5 is 25. So there actually are two answers to this, right? The original, which was 5 times 5, is equal to 25, and the other one where both of them are negative is equal to 25. So again, negative 5 squared is equal to 25, because a negative times a negative is a positive, and 5 times 5 is 25. So the answer to that is both 5 and negative 5. Those are both answers to that. Those are all the square roots. So next we want to find all square roots of 64. Same kind of question. What times what is equal to 64? Well, 8. But it's not just asking about square root of 64, it's asking for all, so we have to include negative 8, right? Because 8 times 8 is 64. Find all square roots of 169. It's going to be 13, because 13 squared is 169, or negative 13, because negative times a negative is a positive. So we can find all the square roots of 100 over 49. What that's really saying is, what's the square root of 100, which is 10, right? So again, 10 squared is equal to 100. And the other one is 7 squared is equal to 49. But it did say find all the square roots. So this is going to be both a positive 10 over a 7, and it's also going to be a negative 10 over a negative 7. Find all the square roots of 1,600. So the square root of that, you probably want to use a calculator for this, but the answer is going to be a 40, because 40 squared, 40 times 40 is 1,600. But they did say all square roots, so we have to include both the negative 40 and the positive 40. So now we want to simplify square root of 25. Now technically, that symbol right there is the principal, or the prime square root, which is basically positive, right? So principal square root is the positive one. So this symbol right here only wants you to include the positive square root, which is just a 5. 5 times 5 is 25, therefore the square root of 25 is just a 5. So the difference between this and the other one is that one said all square roots, and this one uses this symbol, which is just technically the positive square roots. So the positive square root of 196 is a 14, because 14 times 14 is 196. You can use your calculator to get that. Square root of 9 is 3, because 3 times 3 is 9. Square root of 64 is 8, because 8 times 8 is 64. Number 11, simplify. So we have a negative in front of a square root of 225. Now we're just going to carry this negative over, because we're only, in order of operation, we're going to deal with the root first, and then this is basically the equivalent of a negative 1 multiplied, and we deal with multiplication after the exponent in PEMDAS. So we carry around the negative, and we take the square root of 225, which is a 15. And because of this, we only take, because of that sign right there, we only take the principal, or the positive one. Next one, we take the negative square root of 36, so we carry over the negative, and then we take the square root of 36. 6 times 6 is 36, so it is a 6. Next, we want to find the square root of 0.36. We could use a calculator for that, and that would actually give us a 0.6. Next, we want to take the square root of 529. Find the square root of the radical expression. Excellent. So we have a 23. Let me just do that on the calculator. This should be the negative square root of 100 over 9. So we carry over the negative. Then we take the square root of 100, which is 10. We put a 10 on top. Then we take the square root of 9, which is a 3. We put the 3 on the bottom. That gives us negative 10/3. Over here, we take the square root of 196. So that's going to give us a 14. Find the square of the radical expression. So we have negative square root of 20, and if we square that, a negative times the negative is a positive, and if you square a square root, these basically cancel out. So there's an understood or an implied 2 index there, and these basically kind of cancel each other out, leaving you just a 20. So when you square a square root, you get back the radicand, the stuff, the meat underneath the radical symbol. So if you take the square root of, if you square the square root of 2 over 5, you end up with just simply 2 over 5. Without using a calculator, determine between which two consecutive integers the square root lies. Okay, now what they're basically saying is, if I know 8 squared is equal to 64, and I know 9 squared is equal to 81, I know that since 68 is in between these two, that it must be somewhere between 8 and 9. Over here, the same kind of process. We know 9 squared is equal to 81, which is less than 92. We know 10 squared is equal to 100. Therefore, since 92 is in between there, we know the square root of 92 is somewhere between 9 and 10. Next, we know we have a negative square root of 93. Same kind of process as the previous problem. We know 9 squared is 81. 10 squared is 100. Since 93 is in between there, we know it must be somewhere between 9 and 10. But this one's a little bit different in that since there's a negative in the front, it's somewhere between negative 9 and negative 10. Okay, so we're going to find the missing dimensions of the figure shown to the right and round to the nearest tenth. Now there's something called the Pythagorean Theorem. The Pythagorean Theorem states that basically a squared, this leg, plus b squared, this leg, will be equal to c squared, this unknown right there, right? So again, the formula is a squared plus b squared is equal to c squared. The square of one leg plus the square of the other leg is equal to the hypotenuse squared. Now this only applies to right triangles, and notice there's this little square there in the corner there that indicates that these are both, and both these problems, these are right triangles, so we get to use the Pythagorean theorem. So now we're going to plug everything in. So we know A is 11, so I plug in 11 in. We know B is 13, I plug in the 13. And we don't know what c squared is. 11 squared is 121, 13 squared is 169. So we're going to say that's 0, 9, 2. So it looks like a 290. Okay, so we say 121 plus 169 is 290. And that is equal to c squared. Well, how do I just get c, not c squared? Well, I'm going to take a square root. Whatever I do to one side, I do to the other. And that would give me the square root of 290 is equal to c. The square root of 290 is approximately 17.02938, on and on and on. Now, since I'm only interested in rounding to the nearest tenth, I'm going to look at the tenths place, which is a 0, and to the right of the tenths place is the hundredths place, which is a 2. If it's 0, 1, 2, 3, 4, then I'm going to round down. If it's 5, 6, 7, 8, 9, I'm going to round up. Since there's a 2 there, and this place right there, I'm going to round down, which just means all this goes away. So what we end up with is approximately a 17.0, or just 17. Find the missing dimensions of the figure shown to the right round to the nearest tenth. So again, we have a right triangle, except this time, instead of the hypotenuse being missing, turns out one of our legs are missing. Okay, so in this case we have one leg is 20, one leg is unknown, and the hypotenuse is 52. So we still do the same, use the same formula, a squared plus b squared is equal to c squared. We plug everything in, so we have a 20 squared plus b squared is equal to c squared, which is 52 squared. Now, 20 squared is 400 plus b squared is equal to And 52 squared is 2,704. Now, it doesn't matter which one of these that you label A and which one of the legs you label B, but it is imperative that you label the hypotenuse C. So you can exchange the A and B for the legs. Doesn't really change the calculations, but you do need to make sure that you put the C, label the C correctly as the hypotenuse. So next I want to get the B squared by itself. So I do that by getting rid of this positive 400 by subtracting 400, and whatever I do to one side, I do to the other. Those cancel out, leaving me B squared is equal to 2,704 minus 400, or 2,304. Next, I want to take the square root of both sides. B is going to equal to the square root of 2,304. And the square root of 2,304 is 48. Don't even need to round that one. Next, we have 24, the next problem, which is another right triangle. You can because you have that little sign right there, the little right triangle square in the corner. So that means A is unknown. B, we can just say B is equal to 24, and then we can actually say, C is equal to 24, the hypotenuse, and we would say B is the 15. You can always tell which one the hypotenuse is because it's directly across from the right triangle sign, right? So this is always going to be a hypotenuse, the one directly across from the right triangle sign. So we're going to use the Pythagorean Theorem again. A squared plus B squared is equal to C squared. We're going to plug everything in. We have an A that is unknown, so we just leave it as A squared. B, which is 15, so we're going to square the 15. C, which is 24, and we are going to square the 24. So we end up with A squared, which is equal to 225, and 4 squared, which is equal to 24 squared, which is equal to 576. 576. Next, we're going to try to get the A squared by itself, but we need to get rid of this 225. We do that by subtracting 225. Whatever we do to one side, we do to the other. It gives me A squared is equal to 351. Next, we want to get the A squared by itself, so we undo the squaring of A by taking the square root of it. Whatever we do to one side, we do to the other. That gives me A is equal to the square root of 351 is equal to 18.73499. It just keeps going on. We want to round to the nearest tenth. The tenth place is the 7, and to the right of the tenth place is the 100th place, which we have a 3 there. Because it's 0, 1, 2, 3, or 4, we round down. So we end up with 18, and this is approximate, so it's a squiggle, 18.7. So it's approximately 18.7. That leg, the missing leg right there,